This is a screencast for section 9.1, example 2. Now we're going to look at a series that converges. So I'm giving away the end of the movie, sorry. Does this series converge? Well, we have 3/10 plus 3/100 plus 3/1000. So let's look at the etc. So let's look at the sequence of partial sums. So the first would be just 0.3, 3/10. Then we're going to add 3/100. So now we have 0.33. Then we're going to add 3/1000. So that's 0.333. And you get the idea. We could keep going. Each time we're adding on a new 3 at the end of your value here. But the basic idea is this sequence has a limit of 0.3 repeating, which is 1/3. So if we keep adding and adding and adding, we're going to get another decimal place in 0.3 repeating, which is 1/3. Therefore, the series converges to the sum 1/3. Now also, you can notice that the series, these values do approach 0. They're getting smaller and smaller and smaller as we go. So the farther out we go looking at our terms in the series, the closer they get to the 0, which also gives us a hint that they're going to converge. Now try problem number 9. It says compute the limit of the partial sums to determine whether the series converges or diverges. Well, those decimals are pretty easy, but let's just convert those right away. So 1/2 is 0.5, 1/4 is 0.25, 1/8, etc. Now, if we look at the sequence of partial sums, the first one is just 0.5. Then we do 0.5 plus 0.25, so that's 0.75. Now we're going to add 0.75 plus 0.125. Then we're going to add 0.0625. And then we could keep going for 1/2 to the 9th being our last term we add here, just for the fun of it. And you can see that these values are getting smaller and smaller and smaller in the series, and getting the partial sums are getting very, very, very close to 1. This series has a limit of 1, therefore the series converges to the sum of 1. And like we said, the terms of the series, they approach 0. These values are getting smaller, 1/2 to the 10th versus 1/2 to the 20th. They're going to keep, and then 30th, and etc. You're going to get smaller and smaller and smaller as the terms in the series k goes to infinity. And therefore the series is going to converge, because you're going to be adding on something that's so insignificant, the actual value isn't going to change much.